Hi, everyone, and welcome to the beginning of our webinar series. This summer, we're going to be going through a series, and the message is basically going to be about going from lab to industrial and the evolution and scaling of the cannabis and hemp industry in the extraction process. Today, episode 1 is called The Scaling Menace, and we'll really be focusing on an intro to scaling your operation, the advantages that come from it, the challenges that also come along with it, the importance of it, and the evolution of the industry. So with you today, we have myself, Kyle Georges. I'm the Vice President of Sales and Business Development here at Maratek. And Lucas Palumbo will be the second speaker, taking on for the second half of the presentation. And he's our Senior Automation and Process Engineer. So the agenda for today, to start off, for those of you who are maybe not too familiar with Maratek, we'll start with a high-level introduction and background about who we are, our history, when we came into the cannabis industry as a whole, and our high-level overview of our technologies. From there, we'll really move into the cannabis and hemp oil production process. So for some of you who are maybe a little new to the process, this will just be an overview of kind of what the process is, and when we're talking about closed looping and automation, what we're referring to. And then from there, we'll get into part 3, which is kind of the bread and butter or focus of this webinar, where we're going to be going over closed looping and automation, and also the safety and regulations and efficiency, and basically the importance of automation and closed looping as a whole and some of the challenges. And then to round things up, we'll give a small preview of the next webinar, episode 2, Attack of the Solvents, where we'll be really diving into the whole bottleneck that solvents bring into this sector. And then from there, wrapping things up with a question and answer period. So a little introduction about Maratek. We've been around for over 50 years, and we're located in Toronto, Canada, about 30 minutes north of the airport. And our history as a company comes from the solvent recycling and hazardous waste processing industry. So be it everything from pharmaceutical, food, paint, printing, automotive, aerospace. We even have systems in some of the nuclear power plants here in Ontario, Canada, just outside Toronto. And the big thing with all those industries is they're very regulated industries, be it from a safety standpoint and dealing with very hazardous solvents and other materials, to also compliance needs, be it for pharma, food, and other industries. So it really gave us a lot of experience really coming into the cannabis and hemp industry, which really happened about 6-7 years ago, is where we really began to grow into this sector. And the way we actually began in this sector was one of our clients in Colorado called us for a fish oil and ethanol IPA project. And it wasn't until our technician got out there that we found out that it was actually for cannabis. So it was a big new evolution for us as a company. And now cannabis and hemp does make up over 75% of our business. So it really has become kind of our focus. And with our initial entry into this industry, it really was around solvent recycling and recovering the solvent out of the oil. And that really led to the development of our ORA series, where we didn't just recover the ethanol out of the oil, but we automated the 3 steps of bulk recovery, residual recovery, and decarboxylation all within one system. And we'll dive into that and some of our technologies a little bit later in this webinar. So now to jump right into the webinar process. So on that, a high-level overview of the cannabis and hemp oil production process. Well, the first step is the inbound biomass. You got to be thinking also about how that biomass is being received. Is it super sacks? Is it in barrels? Is it wet and it needs to now be dried? Is it already pre-ground? How are we going to be unloading it and bringing it into the plant? And that's really the main focus, the main entry point of the production process. From there, we get into extraction. Now, on the extraction side, there's a few different types of solutions regarding the technologies that can be used, but the main 2 right now in the industry, we would say would be ethanol extraction and CO2 extraction. There's also butane extraction, other hydrocarbon extraction, rosin presses, water-based extraction methods. But CO2 and ethanol are kind of the main 2 right now in the production process. From there, we get into filtration, which is really 2 steps on the filtration side. The first step there being filtering out the plant material after the extraction step. But also, depending on the type of extraction method that you do, you might be carrying on a lot of fats, waxes, lipids within the oil. So you might need to do a whole filtration and possibly even winterization step to pull those out of the oil. From there, we get into the recovery stage and decarboxylation stage. Now here, what we're talking about in the recovery and decarb stage is basically the 3 steps of bulk recovery, where a lot of people use, initially a lot of people at smaller scale just use rotovapes, but as they scale, they look at other lab technologies like film evaporators for the bulk recovery stage, From there, possibly going into a rotovap or another system for the residual recovery for the little bits of ethanol that are left over after the falling film system. And then the decarboxylation step, which is activating the cannabinoids within the oil. Then we have the dewatering or reproofing stage. Now, depending on how you're doing your recovery and decarb and also your extraction step, you might be carrying a lot of water over from the biomass into your ethanol or other solvents, slowly degrading the proof, which will affect your extraction efficiencies. So then depending on that process, we have solutions there to automatically inline reproof. And some groups too, depending on the recovery process they use, will pull out, more colored ethanol with other volatiles within there. So also cleaning up that ethanol so it can be reused, continuously in your extraction process. And from there, we go into post-processing, where we would talk about, doing distillate production, isolate production, or whatever other final process you'd like to do, depending on what your final product would be. So to start things off, the importance of automation and closed looping. So the question really is, why automate and why closed loop? Next slide. And here what we've done is giving you a general high-level overview of that extraction process, right? So here we're referring mostly to a cryoethanol extraction process. You have your biomass feed in. Then from there, you have your extraction step, either CO2 or ethanol. The winterization step's optional. When doing CO2, you end up with carrying over a lot of those fats and waxes that I was referring to, where you would winterize to freeze them out. Just like when you put, for example, your soup in a fridge overnight, and you collect that fat layer at the top. So to winterize your solution, you basically pull out the fats and waxes thereafter with the filtration step, whereas doing a cryoethanol extraction process, you could completely skip the winterization step, as you wouldn't be pulling all those other things out of the plant into your oil. From there, then we'd go into your bulk recovery step, your residual recovery step, and decarboxylation. And this is where our Maratek Ores 3-in-1 solution really can take those 3 steps. So rather than using a falling film, then a rotovap and a decarb reactor, automating all those 3 steps within one solution to a heated oil storage. And then you see there at the bottom, from a closed loop process, you would bring your ethanol back over to your ethanol extractor, well, your cryo chillers first, and then feeding into your extractors in a closed loop process. And if you are carrying over water too, in that stage is where you'd close loop into what we consider our F series, or another system could be used as well to reproof in line your ethanol process. Now, the big thing is, why automate? Why closed loop? Well, the cannabis and hemp industry come from a gray and black market. And back in those days, having a 10 or 20 liter rotovap would make you the biggest guy in the province or the state. But when scaling your operation, be it to just a few hundred pounds a day or a few thousand pounds a day, you really got to think about the efficiencies that are really going to come into play from closed looping and automating this process. It'll also especially help, like one area that a lot of our clients, we see a lot of losses on, is just ethanol losses. When you're dealing with open containers of ethanol, 2 things. 1, you have the ethanol evaporating continuously, but also 2, ethanol is amorphous. So it's absorbing the moisture out of the air, and your ethanol grade is actually going to be decreasing just from having open containers. You're also going to have increased ethanol allowances. A lot of issues that the industry is running into as they're looking to scale is increased regulations for having more solvents on site. One way to help avoid some of those things is by closed looping the process. So that way you can have more ethanol on site and not have to deal with, necessarily building full C1, D1 environments. Also on there too, reducing your environmental footprint. A big thing is, well, solvents are, are not the most environmentally friendly substances. So any chance you can to reduce that, we're a green industry after all. So that's a big step. But then it really comes into, on the next side, is from reducing contaminants. During these extraction processes, we're seeing a lot more of the industry pushing more and more towards GMP compliance, towards pharma, right? Whenever you have an operator dealing with the substance and he's carrying it around or anything of the sort, there's always an opportunity for operator error. So by automating and closed looping a process, you greatly see a reduction of those issues. And also of contaminations that can be caused, just from even having your oil in an open container, you can get contaminants that way. But also you see further benefits from reducing the labor costs, because now instead of having, a room full of falling film systems and rotovaps and different extraction units and so forth, by closed looping and automating that process, you basically streamline that efficient process, and you can take your team, your existing team, and scale and achieve a lot more production value using your existing labor. And then also it's really evolving the mindset from thinking about the production process of all these small individual systems and really evolving it into a single process, a single control system for an entire production process. And then the other big advantages for those GMP and especially EU GMP is all that batch tracking capability that'll be really brought along from that whole automated step. So you can control every single step along the way, all with controlled tracking for every different batch you do, be it time of day, and everything like that. So if you ever had to deal with an issue of a recall or anything of the sort, it makes it very easy for your team to handle. And really, at the end of the day, it's not us pushing the industry that way. It's really our clients that are really driving us to really continue the developments on this side. For example, one of our technologies, the turnkey automatic winterization systems, where, so for those of you who don't know, if you're doing like a CO2 extraction process, and when I was referring to winterization earlier, what a lot of people do right now is they'll take the CO2 extract, which is like a peanut butter consistency oil, they'll manually mix it with ethanol to basically homogenize the solution. They'll then take it, put in a freezer for 24, 48 hours, generally at minus 20 C, some might go colder. And then after that, take it out, do a manual filtration process. And then from there, look to recover some of the solvent in a falling film system, do the rest then in the next step with the rotovap. And then from there, a decarb reactor. And then finally, they have their oil that they'll be putting into a heated storage vessel, wherever they're storing their oil. So one of our clients actually, when we first developed the TAWS, they came to us with the issue of where they were having operators spilling tens of thousands of dollars of oil on the floor. Just from, during the filtration phase, something going wrong, or one operator even spilled oil on their face and had to take a couple weeks off work. So really, that's where our clients are really driving us to really help them develop that efficient process. So with our TAWS series, we've actually been able to close loop that entire process and automate it. So basically, you just got to feed in your CO2 extract, and it'll automate that entire winterization process right to your full spectrum decarb crude oil out the other side. And we're also doing this as well for ethanol extraction facilities and other extraction technologies as well. And for those of you that are already running an existing operation and going, well, I've already got all these systems. What do I do now? How can I look to make my existing process more efficient, even though I'm running with all these individualized systems? The easiest first step to close loop and help automate your production process and achieve much more production of what you already have is regarding solvent management. So next slide. So here on that side, just to kind of recap back to the previous closed loop system that we were talking about, even if your biomass feed in, your extraction step, your winterization, your filtration step are all being manually done, you could already look at automating that whole recovery step at the end of the line there, your downstream technology of bulk recovery, residual, and decarbing into one system with our ORA solution, but also then close looping that right back to your cryoethanol storage to be rechilled and then refed directly back into your extractors. So that's what we see as kind of the lowest hanging fruit and for existing operations to kind of jump to that next level from an automation and closed loop production standpoint. So now I'm going to be handing it off to my colleague, and who will be taking it, Lucas will be taking it on now regarding the implications of scaling, some more about the advantages as well as some of the challenges.
All right, great. Thanks, Kyle. So as you mentioned earlier, I'm a senior process and automation engineer at Maratek. And the four things I want to touch on today are kind of major things you want to think about looking at scaling up your cannabis or hemp extraction project. So the first would be process design integration. So this would be the discipline where we lay out the equipment in your process, connect it together, and make it all work together as one continuous system. The next is regulatory and jurisdictional issues. So dealing with ethanol and other hydrocarbons puts you in a hazardous chemical process, which calls in a lot of regulations and oversight that you have to make sure you're totally compliant with to operate. Then we go into a little bit of chemical engineering, which is dealing with the actual physical and science challenges of scaling up each step. And then finally, we get to financial risks, which kind of ties into project management and some of the pitfalls that you can fall into trying to execute a larger engineering project. So first, in process design and integration, at a small scale, you can kind of think of each piece of equipment as its own discrete thing. You kind of shop around for rotovap, shop around for a freezer and glassware, and you kind of can place it all in one room, and you don't necessarily have to worry too much about how they're going to work together, because most of the time at a very small scale, it's manual transfer by a worker between steps. could be somebody literally carrying a glass beaker and putting it in a freezer. But when you scale up, I mean, the material handling by personnel becomes completely unfeasible. Even at a couple 100 pounds a day of biomass in, you're going to need to design hard pipe connections between machines, which these could be sanitary GMP connections. But and that also brings in, you may need holding tanks or buffer tanks between machines, pumps, valves. Those tanks would need levels. And all of this, very quickly, it would kind of force a basic level of automation right off the bat. So for example, if a buffer tank was getting too full, you'd have to have a central control computer or PLC slow down the machine feeding it, or speed up the machine draining it, or if the tank got too full, stop the process. And we can do all that. We could send a remote alarm to an operator on their phone or something if that happened. But basically, this level of automation you have to do in your integrator also has safety benefits. You know, a redundant safety PLC would be able to respond to process upsets anywhere in the whole process and safely stop it or control it in a way that wouldn't cause a big problem. So next, looking at regulatory and jurisdictional issues. So as I mentioned, when you're dealing with hazardous chemical processes, it brings in lots of things like area classification, fire codes, building codes, insurance, and basically your process affects the building you're in, but also it affects society around you at large. You know, a great example or analogy I use is a small lab might be like playing music on your phone in a public park. You know, while you're not really allowed to play music, you're not really bothering anybody and you're not going to create a big disturbance, so you can get away with that. But scaling up to a large industrial facility would be like bringing in large amplified speakers and inviting hundreds of people. You know, all of a sudden, now you need permits. Now you need to go to the local government. You might not be able to do it exactly where you want and when you want. The point is, as you disrupt more people and become a bigger interest to society, there's a lot more oversight. You know, rightfully, I think, if you're dealing with ethanol and hydrocarbons, which, especially as we're boiling them, you could create explosive mixtures in the air with the vapor. So we have engineers in-house that have decades of experience executing hazardous chemical processes. So you can be confident that with the right partners, you can get through this process, but definitely requires some professional engineering services. And I can speak to in-house when we do all our electrical and control builds. We have tools in our toolbox like purged control boxes, where we bring in fresh air to a sealed control panel to make sure there's no way any vapor can get in there. Remote class 1, div 1 control tablets. We can use intrinsically safe instruments or explosion-proof instruments. We could use pneumatic control. So we have a lot of tools and toolbox to be able to handle this. And this is all known stuff. You know, none of this is breaking new ground. There's hazardous processes everywhere. These can be executed safely, and you can pass your inspections first round if you know what you're doing. So then I wanted to move on to a little bit more of the chemical engineering challenges. So this gets more down to the science of trying to actually, besides the practical challenge of integrating a process and the regulatory challenge of getting it approved, there's basic physics you need to work with here. So a perfect example, and this actually comes up a lot, would be the surface area and volume problem, or the square cube law. So we can use the example of like a rotovap. So you have like a round bottom flask and submerged in a warm bath, and you're relying on transferring the heat through the surface of the flask into the ethanol inside. So if you just took a rotovap and made it physically 10 times bigger and put 10 times the heating power, it might only be 2 to 3 times faster. That's just because as you make that sphere bigger, you have way more liquid and not that much more surface area. This is just a basic result of geometry. So there's a lot of engineering and thought that goes into dealing with problems like this. Like, for example, we could put coils inside that volume of liquid, add more surface area. We could recirculate it through heat exchangers quickly, just to create a lot better heat transfer situation. And you know, in engineering, there's a lot of solutions to these kinds of problems. And this is huge in solvent recovery, where obviously we need to transfer a lot of energy to the solvent to boil it off and get you your oil out of it. It shows up in other places too, like even in refrigeration, especially for a cryoethanol process where there's huge refrigeration demands. Like a small lab freezer, like your refrigerator at home, would have a canned scroll compressor and an air radiator on the back of it, and that works for that scale. But if you want to go to a factory size with a massive multi-100-ton cryochiller, you're looking at maybe screw compressors, ammonia systems. So just because as you scale up certain kinds of compressors, there's physics, complicated physics that comes in, why you'd want to use different technologies. So you kind of just get into a different realm at larger industrial scale where you need different tools in your toolbox. There's different process you need to use. So scaling is not always very simple. This comes up actually in distillation as well. You see that at lab scale, people do something called short path distillation, but as you scale up, everybody goes to wiped film. And it's just a change in the geometry and the way you spread out the oil in the heating chamber, because it just doesn't scale up very well. You need to use a different technology. This even goes to storage tanks, or sorry, not storage, mixing tanks, where it's not even so simple taking a mixing tank and making it twice the size. There's chemical engineering textbooks written about how the different kinds of recirculating currents create different shear forces on the particles floating in it. So each step here, you need expertise to understand how things physically scale. So then finally, I want to talk a little bit about financial risk. And really this section is all about project management and why it's so key to making these projects go off smoothly. So, you've heard the adage, spend $1 now to save 1,000 later, or, an ounce of prevention is worth a pound of cure. Doing careful engineering design upfront is so critical in this because for a couple of reasons. One is just that these large custom equipment can have very long lead times. And obviously the project has to move forward. Say it takes 24 weeks to get the biggest distillation machine that's ever been built, if you want to build a really huge flagship facility. Well, you have to move forward in your facility before that gets delivered. That means mechanical contractors have to be putting pipe mounts in and piping stuff in. You have to have electricians setting cable trays. You have to put refrigeration equipment in. And so a lot of this challenge is a simple challenge, is picking up the phone. You have to have a project manager coordinating. While this equipment is still a 3D model on somebody's computer, the mechanical contractor needs to be putting the pipe connection for it to just be dropped in and connected. So really good management means when that equipment gets there, it can be connected right away. And this goes to the idea that the cost of mistakes scale with the cost of your project. So on a huge project, if a small mistake is made with piping, now your equipment gets there. Now it's going to be a multi-week delay. You have to bring in welders, cut a bunch of piping up and change it, be very costly and bring a lot of delays in. So having one party basically, or one group, be kind of the prime contractor and managing all this, it can make a huge difference. Another thing to think about is utilities. Oh, sorry, Josh, could you go back one slide? Yeah, sorry. For utilities, we're looking at, as you scale up, energy costs go up. Some parts of the process are very energy intensive. So for example, if you have a large central chilling system, and then you have ethanol recovery, and you want to do it electric so you don't have a large natural gas connection, we could be looking at thousands of amps realistically at not huge scales. So at 460 volts. So that could require, we'd have to look at your facility, and we've experienced doing this too, and understanding you might need to upgrade your electrical substation, or we might need to look at heat pumps. There's lots of options, but all this thing comes into the project management. We get there and you don't have enough electricity. Whoops, now you can't start your process. It can't even be run. So management really, really is key to making these go off smoothly and getting you started, when you plan to. So, in conclusion, I think there's some challenges to this, but I just want to reiterate that while this industry, we're breaking new ground, none of this is impossible by any means. This is done in other industries every day. Hazardous chemical processes are nothing really to be afraid of. If you're working with professional partners, they can be executed smoothly, and you can start up when you want to and get to the production targets you want to. For that, I'm going to hand it back over to Kyle, and thanks for listening.
Well, thank you, Lucas. And yeah, like the big thing with this is it's not just for small facilities, right? A lot of people start thinking about, closed looping and automation or scaling, and a lot of people get afraid, right? But it's not just for facilities that are looking to do thousands, be it a couple thousand pounds a day or 20,000 pounds a day. Once you get to a few hundred pounds per day, like this is really something, we really recommend clients start looking at. Because also with this industry, it's not just making money now. As we all see with the prices of CBD, other cannabinoids, oil, isolate, so forth, it's trending downward. It's a race to the bottom. So the more efficient you can make your operation now, the more things you can do to reduce opportunities for operator error. The more you can do to lower your cost per gram really, really plays into not just today, but the future of your company in this industry. So finding that right group to work along with, be it a project management and engineering firm, or if you can get the best of both worlds and get a manufacturer like ours that can also help you along with the engineering, that's the ideal thing in my world. But that's the key with really building out to that next phase and really looking to make your process efficient. So before we get into Q&A, actually first we're going to be going over some of the questions your team, some of you have already submitted. Josh, go back for a second. I just wanted to quickly give a high-level overview of what the next webinar in our series will be, which will be occurring early next month. Now, on that side there, the next one is episode 2, Attack of the Solvents. And I'm not sure if you guys like our Star Wars theme here. And on there, we'll really be diving more into the whole solvent side of the production process, dealing with those solvents, be it from, there's the bottleneck that really comes in from the recovery standpoint, dealing with residual solvents and that ppm in your oil, the decarboxylation step, discoloration of recovered solvents, water buildup, and also solvent management just as a whole. So please join us. We'll be sending out follow-up invites again for the next webinar as well. But now on to some of the questions that you guys submitted. So on that side, I'm just gonna move this here so I can see the name. There we go. So what major issues are confronting extraction processors? This was asked by Steve. So the major issues confronting extraction processors, on that side there, it really comes down to the increased regulation and compliance needs that are putting onto this sector, right? Like legalization is great, right? It's made an industry that was illegal before illegal, but you have all the other things that come along with it. You have to deal with all the same regulations and laws that come into, how you deal with solvents, store them, the safety, the zone classifications, and so forth. And also on that side, really looking at making that next step in regards to automation. A lot of this industry has a very much a lab scale and lab-minded or oriented mindset when it comes to the extraction process. And that really is the major issue, is kind of making that leap, both in understanding compliance needs and regulations when scaling, but also taking that leap into automation and closed looping and going beyond just being a small lab. All right. So this was asked by David. Are you designing for BPE and 3A standards in all your equipment? And what are you utilizing for your CIP capabilities? Or is your equipment set up for manual cleaning? So David, on that, when dealing generally with pharmaceutical groups in other industries, they come to us with basically an RFQ, a request for quotation, and a detailed URS, user requirement specifications, where they outline really what they need us to build to. And for clients that come to us in this sector, we can handle that as well. So if you guys ever have any tailored pharmaceutical projects, it's not a problem. We do build to 3A standards in all of our equipment, and we can do BPE, but right now we're doing EHEDGE, EHEDGE for our standards on that side. And regarding to CIP capabilities, we can handle both manual and automated. Depending on if we're dealing with more of a custom, larger scale build, we can accommodate either or. And then from the others, like on our OR side, on the SC series, it's much more of a manual clean. Whereas on the C series, it's very much a fully automated CIP process. And there we generally use an ethanol rinse. But for clients that want to use, let's say, a variety of different cleaning agents before then, followed by an ethanol rinse, followed by a wash down, we can also accommodate those things as well from our CIP standpoint. Which extraction method is easier on a micro scale, CO2 or ethanol? From Ryan. Well, really, Ryan, it really comes to, and this is maybe a question that we should discuss a little bit more with you directly afterwards. It really comes to understanding, do you already have an existing facility? What is the zoning you already have allowed, right? Personally, I'm really tailored towards, my preference really is on the ethanol extraction side. But from a CO2 point of view, right, if you have an area where you're not necessarily going to be looking to build a classified zoning area, with CO2, you could greatly reduce the amount of ethanol that you need on site. So it really comes to understanding what you're looking to do and also the end products you're looking to make and the facility you have right now. So then we can advise more easily on which way to go. But personally, if I'm able to deal with the zoning that comes in from having more ethanol on site, my preference is to start with just right into a cryoethanol extraction process. How to remove solids in order. Well, here, Lucas, how about you take this one?
Sure. Yeah, so I can walk you through basically when you have your plant material mixed with the ethanol, I'm going to talk about an ethanol process. We have a couple methods to do the bulk separation and filtering. So when you have your plant material and ethanol all mixed together, you could use at a large scale decanting centrifuges, or which is basically just spinning it really fast and squeezing out the ethanol and the plant material, or you use a screw press. And then once you've done that, you can go on to filtering and then potentially winterization to then get out all the fats and wax that are dissolved in there. Or if you're already cryo or cold enough, you could just go directly to filtering, and any wax you do pull out won't dissolve properly. So that's the first of how you basically remove the plant solids from your extract. Oh, Kyle, I think you're muted.
Sorry about that, I was muted. What extraction process is best suited for large scale production, by John? Well, when people are looking to scale in this industry, right now, the main way people are looking to scale, and when we're talking about large scale production, especially if we're starting to get into the thousands and thousands of pounds per day, we really see cryoethanol extraction as being the leading medium in regards to scaling your process. One of the big reasons for that too is, not necessarily to needing to utilize that whole winterization process. By running at cryogenic temperatures, you can really skip a major production process that is used. There's people also looking to scale with warm ethanol extraction. There's also some people looking to set up very large scale CO2 extraction processes as well. But by going with cryoethanol extraction, you really can help skip one major chunk of the whole production process to help make it an easier process, both from a number of steps, so from a GMP and batch tracking point, but also in a closed looping and automation point. The fewer processes you can do, the less opportunities there's also for something to go wrong in the process. All right, what are the cannabinoid separation process options by Abdul? Lucas?
Sure, so if you want to go straight to separating out pure CBD, we could go through, once you've got your crude oil with all the residual water and ethanol removed, you can go to, this is post-processing, you go to distillation, get to distillate, and then that can be processed to CBD isolate, which can be 99.5% pure CBD powder. If you're interested in other minor cannabinoids or THC, we can take that distillate and do a process called chromatography. We can separate out the different constituents. And if you're interested in terpenes, those can be separated off in the first stage of distillation. So we have science and technology partners that can help you go farther and farther downstream to more specific end products. And this is definitely something we could consult with and help you with this process.
Well, so thank you for joining, but now we'll jump into Q&A as well. Just so you guys know, Lucas and I, you have both our emails there and phone numbers as well. So if you guys do have any follow-up questions or anything of the sort of too, and you want to dive more into our technologies or how we can help you with your projects and scaling, please do feel free to reach out to us. But here, so the question and answer. First one is, why is it called winterization? In the chemical industry, this means that the process system needs to be protected from winter condition elements. To be completely honest, it's probably originates from the slang in the industry from dealing with making something frozen and cold. It's that's really where it's come from, and it's really the name that stuck. I've been involved now in the cannabis and hemp space for 3-4 years now, and that's a great question. Luke,
Yeah,
you
it's
got
kind of an
an answer? 'Cause
informal
that's just,
term, but it's sort of
yeah.
stuck now.
Yeah, it's become a very much a staple name with or term within the industry. The cannabis and hemp industry has lots of, let's say, small lingo and slang that's really developed into the industry to become, let's say, scientific names for processes.
I think it would be like thermal precipitation, or I'm not 100% sure what the precise term is, but we're basically just taking the wax, which is saturated in solution, and we drop the temperature, it's super saturated and drops out and kind of coagulates.
Yeah. And then another question was, I wonder for how long the ethanol can be recycled. Well, in regards to how long the ethanol can be recycled, that really, it depends on how much you're cleaning your ethanol, and it also depends on how you're doing your extraction process. For example, if you're doing a very cold extraction process with ethanol, cryoethanol extraction, and one of the big advantages with cryoethanol extraction is you're not going to pull out nearly as many, also the chlorophyll, but you're also not going to pull out and also a high proof, because chlorophyll is water soluble, you won't pull out as much as that, but you also won't pull out nearly as much for fats and waxes and water as well from the biomass. So then you don't need to reproof it as much or necessarily clean up your ethanol as much. And also, if you're doing a very efficient recovery step, you shouldn't be carrying over a lot of things with your ethanol. One thing that we've developed on our ore series as well is we have a special demister that's been built into all of our systems. It's something that, and like Lucas said before too, it's not always about reinventing the wheel in the cannabis industry, but finding the right things that have already been developed in other sectors and utilizing it here. So in other industries where we had to be worried about oil entrainment or other entrainment within ethanol vapors, we developed our special demister technology to help prevent that. So things like this can help you reuse your ethanol more and more. And then if you are doing other things like carrying over water or other things too, you can look at reproofing and cleaning up that ethanol in line as well. Like that's where our F series really comes into play, so that you can instantly reuse your ethanol. So then their next question was, does cryoethanol extraction eliminate the need for winterization step later in the process? Well,
very good question.
Yeah. So the answer is generally yes. If you're not going cold enough, you might still, some people might look to still do a winterization step, right? So that's where the industry, it used to be minus 20 C. It's now getting more and more colder. Minus 40 C has kind of become a staple norm, especially if we're going from a cryoethanol extraction step. There are groups that do, that, and there's some of our clients too are very insistent about running at even minus 80 C. Now, and then they claim to get much more of, let's say, almost a distillate grade product out the end of the line. So, the colder you go, there's also advantages, but generally, yes, cryoethanol extraction eliminates the need for a winterization step in the process. And that's one of the big reasons why it's easier to scale with cryoethanol extraction over other types of extraction methods. Lucas?
One other minor thing I would add to that is it also depends a little bit on where you want to go at the end of your process. So for example, if we're doing cryoethanol and you want to produce a distillate, well, if we leave a tiny amount of waxes left in the oil, that can be cleaned up at the distillation stage. We go to a 3-stage distillation, or expect our distillation to be derated a little bit and kind of clean it up there while still skipping that step. But if you, for example, don't have the ability to freeze the plant material before you extract it, and you want to produce a very high quality oil directly, then you still might need to do a kind of polishing step. You still need to winterize. You still need to get it to minus 40 for a period of time before you filter it. So it goes into the whole thinking of the process holistically, thinking of what you want to produce and where we can shift the kind of workload and different steps around too.
All right, those great points there to add on. One question was, can butanol be used instead of ethanol? So yeah, butanol, Lucas, correct me if I'm wrong here, but butanol is butane, right? So there are butane extraction processes. People do use butane extraction. It's a much more volatile compound. So generally people aren't looking to scale with butane. You'll be hard pressed to find a fire marshal that's going to let you store, a crap load of butane at your facility, because it's a lot more flammable than ethanol. But there are people running butane extraction solutions. But then a lot of people will also winterize their extract after a butane process as well, depending on what their final product is.
And why you might want to use more standard. Well, ethanol is lighter, heavier alcohols, if you have, takes more energy to boil it, that's just more energy you have to spend boiling it. So there's efficiency things to consider here. And also just availability, using more exotic solvents, either for the main extract or downstream. It's just going to be more costly, difficult to find stuff. Even simple things like seals on pumps and stuff are rated for more common alcohols. As you go to more unusual ones, it increases the challenge all the way up and down the process.
And just to add on to that too, like we also have clients that are looking, well, that extract and also are scaling with hexane, heptane, and other hydrocarbons and solvents there too. One big thing with our group, just so you guys know, is if you are looking to use any of these other hydrocarbons or other solvents or even other processes, is our technologies can handle those as well too. So if you guys have anything coming up on those sides, please feel free to reach out to Lucas and myself too, regarding those extraction processes. So I think that kind of wraps things up, unless anybody else had a few last more questions. For those of you who also signed up, we'll putting, oh, no, that was just the same one. So if any of you have any other questions, please feel free to reach out to us. We'll also be compiling a list of these questions and other questions, people that signed up for the webinar, and the answers, and sending it out to all attendees. If you guys do have any others, please send it out to either myself, Kyle@maratek.com, or Lucas, and we'll be sure to include that in the list too. And if you guys have any other questions, we'll follow up offline. All right. Well, thank you very much, everyone, for your time today, and have a great day.
Thanks so much.
Cheers.